Hi everyone, and welcome to How a Military Strategy Can Help You Secure Your App Deployment Cycle. My name is Melissa Sussman, and I'm the lead technical evangelist. So when discussing his military strategy, Colonel John Richard Boyd once said that time is the dominant parameter. The pilot who goes through the OODA cycle in the shortest time prevails because his opponent is caught responding to situations that have already changed. So what is OODA? OODA is a military term originally coined by Colonel Boyd. So he was a United Air Force fighter pilot and Pentagon consultant. And according to him, the key to victory is the ability to create situations in which one can make appropriate decisions more quickly than one's opponent. While this was originally developed for air-to-air combat, his process easily applies to internet security. This is why OODA loops, were eventually adopted by the Center for Internet Security or the CIS. So taking a templated approach when dealing with app deployments basically frees development teams up to focus on the issues that automation can't necessarily address. So by building and automating essentially an OODA cycle, DevOps engineers and security analysts, security engineers, all kinds of folks working in the DevOps space really are able to speedily pinpoint issues, determine available options, decide on a remediation strategy, and then implement it. So this frees up the team to work on more interesting projects and less monotonous tasks. So what does the acronym stand for exactly? Let's walk through it with a few examples. We're looking at observe, orient, decide, and act. So let's take a look. Here we have observe, detect and prioritize threats. So here, the idea is that you want to quickly detect application and security incidents by doing things like tracking security bulletins and advisories and CVEs, and continuously monitoring your own cloud infrastructure. So you also want to do things like generate actionable security insights by leveraging an on-premise and, of course, cloud data. So monitoring and analytics tools basically surface the most relevant insights via logs, metrics, traces, and events. Utilizing system observability is really key here to enable real-time threat intelligence and protect hybrid cloud environments. So orient, this is where you do some, deep investigations. This is where, live dashboards are going to allow you to utilize interpreted machine intelligence for logs, metrics, and traces to, better orient yourself around observed threats. So this allows you to perform quick and deep investigations on a unified platform. Remember that time is of the essence when dealing with threats, and enriched data on known threats allows your team to accelerate development processes and reduce downtime issues overall. So by diving deeper into incidents and exploring, detected insights, you can better research the applicability of known threats to your environments quickly. Researching the applicability of known threats to your environments is, key intelligence to then determine a remediation strategy. So decide. This is where you determine a remediation strategy. So now that you've quickly observed and oriented, it's now time to decide. So leveraging artificial intelligence for IT operations to improve overall security posture and accelerate incident response times is amazing, right? Okay, but what do we mean by AI ops and accelerating that response time? I mean that by using AI-based parsing utilities, you can more quickly draw your attention to anomalies and identified threats. Then you can remediate quickly via automation. If you want to learn more about AI ops, please visit Sumo Logic's glossary terms page. The link is there in the slides. As we mentioned in the strategy at the beginning, speed and moving through the OODA cycle is key. This enables you to improve overall security posture and accelerate incident response times. The ability to learn and, of course, measure and forecast with machine intelligence allows teams to protect their applications from common and known exploits. This allows you to do things like investigate in high fidelity and AI-interpreted machine data from those logs, traces, and metrics, which then, allows you to reduce the downtime quickly and effectively, thus tightening your OODA cycles. Act. So roll out, monitor, and manage deployments. So here we have a few great examples, things like cloud-to-cloud collection, monitoring via continuous intelligence platforms, and managing via automated CloudFormation or Terraform templates. If there are any threats for which you do not already have an automated response, you can investigate again through another OODA loop cycle. You can essentially use user-level granularity in queries, dashboards, and alerts to pinpoint any of these unexpected anomalies. Of course, this also enables developers to really focus on the things that automation and machine intelligence cannot. So this kind of closes the gap on less known vulnerabilities as well. What are some of the other ways that you can tighten your OODA loop cycle? Well, reducing response times means working as a singular machine. It's important to break down team silos in order to manage an increasing attack surface area. Many teams usually start with solutions that address one or two known threats, but then find themselves dealing a lot with silos. So how much collaboration do you see within your team and between the teams responsible for operations and security? As our customers have embarked on this journey, we see that both security and performance use cases benefit greatly from coming closer together and having one unified approach to manage the application. Technology changes, velocity increases, and overlapping data requirements means that there's a lot more overlap than ever between developer, security, and operations teams. All these factors are driving the need to have a unified approach toward observability and security. So unification enables better collaboration, better outcomes, lower cost, and simplification. However, if you find yourself thinking, that's not my job, I'm an individual contributor, I don't have control over the other teams, you might benefit from the next slide. Shift left in your organization. So on the left, we have the time spent on quality, of course, and on the x-axis, we have the project life cycle. Ideally, the earlier your team invests in quality deployments, the fewer security risks that you face down the line. Colonel Boyd, of course, is just one man, but he was recognized for looking into the importance of a unified front, and he wasn't just some lone military strategist who sequestered himself to a back room or the commander-in-chief. Instead, he influenced Pentagon strategy by enabling flexible, organic whole organizations that were quicker to adapt and act by harnessing the mental and creative abilities of the individual commanders. This concept applies really well to today's DevSecOps organizations, and it works best in groups where there is a high degree of mutual trust and accountability between developers, security analysts, and operators. If you're a developer, you can lead the charge in a shift-left mentality. Of course, creating secure code requires a large organizational effort and culture of accountability from the company you work in. Securing your software supply chain is important, but you run into probably a lot of challenges when your organization is still newer to utilizing these best practices as a unified team. Real-time monitoring solutions help you secure your organization, and it helps you secure, obviously, the code for your customers. Everything from securely accessing code on your application to securing your customer login portals, enables you to contribute to a culture of accountability and shifting left in your company. Instead of having a small number of individual contributors fight a losing battle against bad actors, the shift left culture means that organizational leaders are ultimately accountable for security. As a subject matter expert in development pipelines, putting trust in development teams is essential to getting more out of security infrastructure. If you are developers and you're watching this and you want to learn more about securing your infrastructure, I trust that you will gather all the information you need to safely deploy your code to production. Hopefully your organizations, agree and allow you to take more accountability with autonomy. Now, please join Jason in showing us OODA in action.
Excellent. So let's walk through a typical scenario that can allow you to think about the best approaches for security monitoring and how that's applicable to the overall OODA loop. And again, that's observe, orient, decide, act. And we'll kind of step through each of those with a couple of relevant examples that I think will really help to cement the concept. So again, as we start with the observe aspect of the OODA loop, we can start here with a Linux security monitoring overview dashboard. And we're actually looking here at a combination of kind of successful logins versus failed logins. You can start to develop a little bit of a sense of the kind of threat landscape here for the access to this particular set of Linux resources. So we see successful logins is that 3,993. against 925 failures. So a little bit higher ratio than we might expect, but at the same time, we'll see a couple examples later where access to higher privilege resources actually will have a much smaller number as far as number of failed logins, or a sort of a smaller ratio in this particular scenario. You can also look at these spark lines that can give us a sense of the overall trends as we start to kind of observe in an overarching sense within this monitoring dashboard what's occurring within our system. So we see 1,145 accounts against 523 accounts deleted. So this very well may be in line with expectations for internal IT corporate security concerns, or a set of cron jobs that are essentially allowing for HR provisioning to occur. Or this may be unexpected. We see a number of accounts deleted. This could be indicative of some type of activity that's trying to be tucked away or hidden, or that needs to be investigated. Essentially, in this case, maybe a bad actor that's trying to actually clean up some process that they may have performed. And then we see, and again, we'll get into more detail later in the scope of this demo, the sudo attempts, right? So we're seeing kind of a small trend down over the last 60 minutes of sudo attempts. And then in total, we're seeing 62 services. So again, this is just to help us on the first piece of the observation piece of just kicking off the OODA loop and getting a better sense how to kind of iterate through that. The next piece would be, how do we actually orient ourselves within this set of Linux resources, better understand what's occurring within them. So let's start sort of going a level deeper and looking more closely at the total services being performed, or total services occurring, which are at 63, all these active services over time. And then we actually start to see a set of services that may need to be investigated a little bit deeper. So Pulse Audio, PK Exec, some of these are kind of smaller number of instances, but there is a lot of consistency here. So this would certainly be something that would want to be confirmed against what kind of internal corporate security policies may be that are set up, what types of services we should expect to see. We're starting to really orient and really decide, okay, based on what we're seeing here, what should we kind of expect the sort of a potentially even next step to be, but at least what are the expected types of behavior that we can see. We can actually start to, as we start to think about the orientation, it's even really helpful to start to pivot out against individual destination hosts, for example. So here we can look at an individual destination host of Bruno supercomputer, and we can see based on that kind of filter or template variable that's set up, we can see that 38 services are running on this particular destination host. These are the active services that are associated with it: SmartD, SSHD, etc. Look at the various trends around those, and we have a much stronger orientation around what we can expect for that particular destination host. The next step would be to say, okay, based on what we're starting to see, how can we actually start to think about some of the decisions or the D, right, in the OODA loop here? So we're looking at, in this case, something that's a lot more of an actionable kind of panel that we may want to take a closer look at. So we're looking at the privileged activity exclusively. And as I mentioned, the ratio is actually, we're seeing a much smaller number of failures against a much higher number of attempts, because these are all pseudo attempts for a much more privileged set of resources that we need to be concerned about. All of these high side of this threshold that's established within these outliers, each of these would be points of interest where we'd actually want to understand better what the associated destination users or destination hosts are that are associated with each of these outliers, because it's indicating potentially, for example, a brute force attack or man in the middle, etc., that we may want to actually start to investigate a little bit deeper, better understand what's occurring within that system. And here's just one more example, another dashboard where we can start to think about what are the actually excessive failed access attempts in the login failure outliers. So kind of a similar look at what we just looked at with a couple more filters set against it. So we can start to actually understand individual source IPs that we may want to actually dig into. Or it could be that, in this case, destination host, just to stick with that example, we know for sure maybe that this particular destination host is something that we want to investigate a little bit deeper. And this is where we can actually trigger an alert from each of these panels. We have an individual query that underpins each of these. You save these down as alert. You can send it out as a webhook to Slack or Microsoft Teams, etc. And then that's where you can actually complete sort of the OODA loop, right? And say the A in the OODA loop being act. How do we take an action such as quarantining host, for example, directly against that particular alert and make sure that we're, taking all of the right actions as we consider which of these are the biggest security concern that we want to actually dig into. The final step that I'll just add an extra A after this, just since it keeps us within the OODA loop concept. We could also look at ways in which we could automate a lot of that action that's being taken. So we now are looking at threat response strategy, talking through that. How would you actually automate that through, for example, an orchestrated or automated playbook within a cloud source solution such as Sumo Logic? So I'll just kind of put a nice bow on it here and close things out. I hope this is really helpful for thinking about how the OODA loop concept really can apply to, taking a very kind of hopefully clever approach for whatever resources you're looking to protect, and really thinking about how to monitor the most security relevant data sources to actually execute against that. Thanks so much for joining this session on OODA loop. Feel free to ask us any questions you may have. Thanks so much.
Thank you for joining us. I hope you learned a lot from this session, and I hope you enjoy the rest of the Illuminate sessions.